Okay. So first topic we start with is oscillations, right? What is oscillation? To and fro motion, right? That is oscillation. Oscillation can be compared, like we know waves, है ना? Waves oscillate. So whatever we knew about waves would also apply to oscillation. Oscillation is the motion. Wave is a trace of that motion. Like you can say something like this, है ना? Now ભાઈ એસી કરી દે થોડુંક કરી દો તો મજા આવી જશે આમ પણ રિમોટ નથી ક્યાંક Okay, so we know that waves have time period. નથી તારી પાસે નથી તું બીજી what is this? Then you have wavelength, right? Then we also have frequency. We also have wave speed, which is known as angular frequency, right? And we generally represent waves on axis such that they are sinusoidal waves, right? Sinusoidal wave has a period of 2 pi. So we will consider that our ideal wave will have a period of 2 pi. Then we will find out if it has a shorter or longer period, right? If you can imagine it like this, that this is your amplitude, which is your y, and this is your displacement, which is considered as x, right? You can write y is a function of sine theta, right? Y is a function of sine theta because that's a sinusoidal wave, right? Y is displacement here, but you can multiply it with the number a, right? Amplitude. If there is a multiplier, a scalar is multiplied. If the value of a is 5, then your amplitude will be plus or minus 5. And this theta can be substituted by writing angular velocity into the time t, right? So this becomes a dynamic formula, right? Now if this is understood, working with y is equal to, shall I write y0 sine omega t? Yeah. Right? Y0 is the maximum value of y. Okay. And if this is displacement, right, in terms of wave, you should have that y dash is equal to y0 cos omega t into omega. है ना? So this can be written y0 omega cos omega t, right? Now this is differentiated with respect to time t, है ना? Only then this becomes velocity. Displacement upon time becomes velocity, rate of change of displacement, that is velocity. Then if you find double differentiation, you will also find that this will become minus y0 omega square sine omega t. Yes. Correct? Is this making sense to all of you? And what is this? This is nothing but acceleration. નથી ટેક્સ્ટબુક તો મને પૂછીને ગયો તો હું તને પહેલા કહી દેતો. Right? Now, can I also write down, see, this is nothing but acceleration, this is velocity. So can I write acceleration is equal to minus of omega square into y? है ना? In our textbook, they have said that y is nothing but displacement. So textbook says that a is equal to minus omega square x. है ना? Here acceleration and displacement are in opposite direction. That is what the sign minus signifies, right? With this, a body that obeys this equation is undergoing a simple harmonic motion. है ना? Makes sense? Now, what does this mean? Let us take a pendulum, right? Whenever pendulum is exhibiting a to and fro motion, right? It has maximum velocity at, है ना? So it has zero acceleration or nearly least acceleration, है ना? As and when it goes away from the mean position, the resistive force or the restoring force, right? Wherever there is acceleration, there has to be a force, not restoring force. Wherever acceleration, there has to be a force, है ना? If acceleration is not equal to zero, then there is a equilibrium not established. There is a force, right? There is a resultant force, है ना? If there is resultant force, what is that force in terms of oscillation? That force is restoring force, right? Because of this restoring force, what happens is basically this equation A is equal to minus omega square into x. This tells us that if it goes away from mean position, the restoring force increases. The restoring force is maximum at extreme position, the end, right? The end point of oscillation, that is extreme position. At extreme position, it has the most restoring force, and then it starts restoring, it starts taking that back, right? When it reaches the equilibrium position, the restoring force is zero. Then why does this body overshoots? Why does it go in the opposite direction? Huh. Huh? Exactly. My question is the same. If the resultant force becomes zero over here, why does it go in the opposite direction? It shouldn't, right? It still has. Okay, in terms of force, can you describe if it still has velocity? What does it have? So kinetic energy. So what? Okay, it has kinetic energy, right? It has least potential energy and the most kinetic energy, right? At this mean position, the equilibrium position, it still overshoots, right? The answer does lie in kinetic energy and potential energy and all of that, but there is a simpler explanation available. Can you guess? What should it be? Yes, it has inertia, right? Newton's first law, right? There is no force that is opposing this, so it has inertia. It keeps on going in this direction, and then it again goes up because it has energy. Obviously, it reaches a point where the restoring force is maximum again. Make sense? है ना? This is how this oscillation is made. What if I design a system where it reaches the extreme position? If this thing is disturbed, right, there will be restoring force. The restoring force is such that it wants to bring this to the mean position. What if I design a system where it never overshoots? It just restores it only to the mean position. Do we know any system that does this? हाँ, बस सेंटर पे ले है ना? तुम लोग कुछ डिस्टर्ब करो, वो बस सेंटर पे लाके उसको छोड़ देता है, ना उसको ओवरशूट होने देता है, ना उसको फास्ट सेंटर पे लाता है. कौन सा? अरे भाई वो ब्रो, that depends, that is about the center of gravity. Yes. What is a system that we know does critical damping? A very very basic system. ये अपना जो डोर है ना, if you leave it, what will happen? It will only go till its equilibrium position, है ना? It will get slower, right? So what is happening? There is some force that is absorbing this energy such that when it reaches equilibrium position, its all inertia is removed, its energy is absorbed so that it cannot overshoot. That is critical damping. When you exactly bring it to position, that is critical damping, है ना? Right? There can be very heavy damping. What can that do? That does not bring it to its equilibrium position in half time period, basically, right? Even one time period. Let's say that this is what the wave would have looked like. Okay, if I take it here and it reaches back around this time, then that is critical damping. Okay, brings it back, slows it down in this region, that is how it brings it back, right? It is absorbing. हो गया ना भाई, जीरो हो गया फिर. लाइट डैम्पिंग में क्या होगा भाई? लाइट डैम्पिंग में कुछ ऐसे होगा, it will oscillate for some time, right? Maybe one and half, but it will definitely overshoot once. That is light damping. And in light damping you should remember that the time period remains the same, है ना? And then हाँ, right, not exactly here, but it will get over before the first time period gets over, right? That is critical damping, right? Then this is light damping. Basically damping is absorbing energy such that it does not go on oscillating, right? Now, so now we are talking about how do we absorb this forces so that damping happens, correct? If we can apply force to remove damping, can then there be a force where we continuously make it oscillate? For example, this was a pendulum, right? I need to disturb it only once and then it will keep on oscillating, right? These are. Can there be an oscillation where I continuously keep on applying force on it? Car engine, right? The piston cylinder arrangement, it is oscillating, right? That is a forced oscillation, right? There can be a lot of example of forced oscillation. These forced oscillations can also produce resonance, right? If the forced oscillations, or if the uh, vibrations, the frequency of the vibrations produced by these forced oscillation match the natural frequency of the object, it will resonate and it will exhibit. What will it exhibit? Higher amplitude that it can break. An example is opera singer breaking a glass. We had seen that video in class. Professor Lewin, I think, है ना? Strobing light, right? So that was resonance, right? One more example that a lot of textbooks use. To nahi my class. A lot of textbooks use is if a what do they call this? Soldiers break their march on a suspension bridge because it may cause resonance and it may break the bridge. So that is there, right? Makes sense till here, right? Let us look at some graphs from the textbook to understand what a few things look like. Okay, so the first thing that we have is free and forced oscillation. How do you observe oscillation? Then there are a few graphs. One important graph that you can look at is just a second. Yes, on page 372, you can open your textbooks on your phone if you have it on your phone. Images of textbook, whatever way you have it, right? And you can see that there are three graphs on page 372, figure 18.15. Yes, the three graphs. The first graph is of displacement amplitude, है ना? Then the second graph is velocity. The second graph is clearly a cost graph. Then you look at the third graph, it is exactly opposite of the first graph, the displacement graph, which again proves our logic that A is equal to minus omega square x, right? We know what is the value of frequency, I mean what is the equation for frequency, and acceleration displacement graph can be shown like this, right? Something like this, right? It must have. So on this axis you have acceleration, on this axis you have displacement, right? The greater the displacement, the greater the acceleration, right? On extreme position, there was greatest acceleration, mean position, zero acceleration. Again, you have opposite direction, opposite acceleration, right? Out of the two sides of oscillation, one of them is positive, one of them is negative. Makes sense, right? What are these? These are amplitude, है ना? The extreme positions. For that, yes, maximum displacement from the mean position, right? Now they have directly given this equation. We know from the first chapter or the second chapter, circular motion, that v is equal to r omega. You can replace this r with x, right? And in this simple harmonic motion, let's say I want to find out velocity at this position, right? So there is not a lot of derivation given, but x0 square minus x square is what you have to use, square root of this thing. What is x0? X0 is the maximum displacement, x is the displacement at this point. That will be the velocity of the object, because we know that the velocity continuously keeps on changing. The angular velocity remains constant, but the linear velocity keeps on changing due to restoring force. The restoring force is linear, the acceleration is also linear, right? So that is one equation they have shown us. The oscillations decreased by 5 centimeter or 3 centimeter. So x ને આપણને 7 લેવાનું. No, decrease by 3. So 5 and the other one is 2. अच्छा 10 છે, decrease by 3 तो 7. हाँ, decrease. So I think there was a question that it was 2.9 and that there was a decrease of 2.3. So yes, you had to subtract that. Acha, they have also given a time period, the equation with respect to m by k. Now this is not generally used, but you should know that this equation tells us, see, in a simple pendulum, the mass of the pendulum does not affect the time period. But if it is a spring mass system, the mass of the spring and the stiffness of the spring constant affects the time period, and this is the equation that governs that time period. Okay, so this is how it is, right? You may not need to remember this, but it is always helpful to know this, right? What if you have some equation where they have told you that this is this, and now equate that, what does mean gravity in this equation, what is L in that equation, whatever. Then we must also remember that the total energy in the whole oscillation remains constant. Potential energy, if it is a spring mass system, then elastic potential energy. If it's a pendulum, then simply gravitational potential. Yes, the logic is still same. At the center, આપણને મળશે the kinetic energy is maximum, and at extreme positions potential energy is maximum. That remains true for all of them. Then on page 379 they have given how a damped oscillations graph changes. The amplitude decreases for damped oscillation, right? Energy and damping, right? What happens to the energy? The energy is absorbed, right? Some other things take up this energy. One more example, if you want to think about it like that, is your car suspension. The springs, right, they provide cushion, but if there was no energy absorbance, the spring will continuously compress and expand, right, giving you a bouncy ride. But with spring there are hydraulics connected. So what do these hydraulics do? They absorb the energy, provide damping to the whole system. So car vibrates just once and not continuously, right? Then they have given resonance. After resonance they have given that what happens to the amplitude, how can resonance be prevented, or how can, even if a system is in resonance, can be prevented from failure. Look at figure 383. They have shown that 383, look at 18.34, right? Topic 80, sorry, figure 18.34. There they have given how light damping, heavy damping and undamped oscillations, how do they change the vibration, right? So a heavily damped oscillation or a heavily damped body does not have a lot of change in its amplitude, so it can be prevented from failing. Then they have given medic, and also on next page 18.35, Kenisha, you can see they have given a critical damping ka graph, right? Then big ideas in physics, I think you can read that, but using resonance, magnetic MRI is magnetic resonance imaging, right? We magnetically make okay, we can magnetically make red blood cells resonate to an external magnetic circuit, because red blood cells contain hemoglobin, this heme group contains iron, and then we can observe anomalies in the body. That is what MRI scan is. Okay, now if you will give me 1 minute, we will then start with thermal physics and ideal gases, right? Okay. Next topic. Ideal gases. Thermal physics, and then I. Okay, let's discuss it like this: thermal gases, thermal physics, and ideal gases. Okay, together, right? First thing that we understand in this is what are. Let's understand it like this. हिल साथ में कर रहे कोशिश, right? What are ideal gases? वहां से start करते, right? Any gases follows PV by T equals to constant. Okay, right. PV by T is a constant. We found out through experimentation this constant is nothing but N into R. PV equals to nRT, right? Where pressure is in Pascal, volume is in meter cube, and temperature is in Kelvin, right? So this is a thermodynamic equation. Now, what does this thermodynamic mean? Right? If this equation is a thermodynamic equation, we also need to understand every state of matter very briefly, right? Anything that has mass and occupies space is matter. Any matter is made up of particles. These particles continuously vibrate or move depending on how closely they are packed, right? Because they vibrate, they have kinetic energy. Because there is gap between them, they have potential energy, right? We are talking about only spheres right now. If they are made of small spheres like marbles, then we can think of only kinetic and potential energy. But imagine oxygen gas. Oxygen gas has a diatomic molecule. So that diatomic molecule can rotate like this as well, can go forward. So there are a lot of types of energies that it has, right? Transitional energy, rotational energy, right? All of these energies can be clubbed under one word: internal energy. This internal energy cannot be measured directly. You can only measure change in internal energy, right? In the internal energy is, because we only measure its change, it is denoted by delta U, right? Now this internal energy, how can you change internal energy? The so if you supply heat to it, right, its kinetic energy and potential energies will change, right? What is internal energy? Total of kinetic and potential energy of the particles of a, right? So that is internal energy, right? You can change the different, gaps and the motion by two ways. The first is you apply heat to it, right? Or you extract heat from it, right? How do you apply heat? You keep it on top of a flame. How do you extract heat from it? Keep it in something colder than the temperature of that body. It will lose heat to the colder body, right? Heat only travels from hot to cold, right? If you want to travel from cold to hot, you have to give some work to it, which brings us to the second logic, that you can also compress or expand this thing and you can achieve change in internal energy. So internal energy change is equal to Q plus W. This is first law of thermodynamics, right? If they ask you that what does Q mean? Q means the energy supplied to the system. Because we have written plus, so you have to write to the system. Work done on the system increases the internal energy. If the system does some work, its internal energy decreases, right? If it gives out some heat, its internal energy decreases, right? And wherever there is a cycle, right? Let's say suppose there is a cycle that looks something like this: point A, B, C, and D, right? So if they tell you that you go from A, B, C, D and back to A, then the change in internal energy has to be zero, considering that this is P and this is V, and they have told you that during these, like they would have told you that in which change, what is the work done on the gas, right? Or told you some indirect way where you have already found out the work done in that question, right? But wherever it's a cyclical process, understand that the internal energy change of the system is zero, right? What does this cycle work for? logically this cycle is either changing work into energy or energy into work, right? These cycles are used in car engines, bike engines. You can also say this is also used in refrigerators, air conditioners, right? So that is what these things do. We provide electricity or fuel to it, it changes into work, right? The refrigerator is doing some work in taking heat from a colder region and giving it to a hotter region, right? Yes. हाँ. Yeah, but generally out હોય છે, right? So that is what it is, right? Whenever state is changing, now you tell me, whenever state is changing, what is changing? So let's say I am taking an ice cube, right? And then I am changing it to liquid. What happens? Okay. Internal energy will increase, but will it only increase due to Q? On the system or by the system? System expands, right? So when you compress it, you are doing work on the system, but when the system expands, system is doing work, right? So we have seen such question where they ask us that what is happening. So can you say that the Q, right, for the same internal energy change, as it starts expanding, the heat energy required to keep on making this change changes. So the specific heat capacity is not actually constant. We consider it to be constant, but as soon as you think about from the perspective of first law of thermodynamics, the C is not constant. So we did this in a paper recently. So is it that there is work done, but then when the change the thermal energy supplied is way larger than the work done by the system, hence the internal energy keeps on changing. Yeah. There is no question about it. But what happens is, let's say it was ice, so you've gone from -10 to -8, right? And you required X joules of energy. Here, W has been done by the system. System is expanding, right? So it is overcoming some intermolecular forces or potential energy rather, right? In that case, what will happen? The energy required to go from -8 to -6 will be different. So no, the specific heat capacity will increase, because now to achieve same change in temperature, you require more energy, right? The mass is same, temperature change is same, right? If you look at this formula, H is equal to mc delta T. This is same, but this increases. Only one conclusion follows, that the specific heat capacity has increased. Makes sense? We have seen such a question in our past paper. ठीक है ना? Okay, this makes sense. So whenever there is state change, you can still consider this equation and answer accordingly, right? Then they've talked about molecular energy. So this is basically Q, right? And W is equal to P delta V, right? You can also derive this. There is a pretty straightforward derivation, that work done is equal to force into displacement. You can talk about this in terms of and derive this, right? I'm not going to go in derivation today, but this you have to remember. Also, I hope everyone knows Kelvin temperature, degree Celsius plus 273, but you should also remember that the change in Celsius scale is equal to change in Kelvin scale. So let's say in the last question I told you the temperature goes from -10 to -8, then delta T is equal to 2, right? The temperature has increased by 2. In this case, never ever, so this is 2 degrees Celsius, but it is also 2 Kelvin. Remember, there is no degree in Kelvin. If you write degree, that will be marked incorrect. Okay, first of all. Second, a lot of you do this, that when you convert this into Kelvin, you write 2 plus 293. This is also incorrect. 273. Because the temperature, so you understood that in degree Celsius the change is 2 degree, right? Let's look at here. So this will be 263 and it changes to 265. What is the change? Right? So what has happened is you have added 273 only once. Actually you had to add 273 twice, and 273 minus 273 is 0. Yes. So either you calculate it before, or you can just find the difference. Difference in degree Celsius is equal to difference in Kelvin. Right? Make sense? All of you? Okay. Then there are explanation of thermometers, how resistance thermometer and thermocouple thermometers differ, but I am not going to discuss about that. I am just going to give it as a self study because it's pretty straightforward and easy, right? You can learn those points, they can ask in differences, obviously. Then what do we have? Then we have understood particles of gas, we have measured gas. They never ask you Boyle's law, they only ask you PV equals to nRT questions, right? In this, what are the equations that you need to remember is PV equals to nRT, right? Where N is the number of moles, right? Now, this number of moles has number of particles also. So, this equation can be basically written as PV equals to NKT. What is K here? Boltzmann constant, number of particles is N, and T is still the temperature. This equation also follows, right? Now, the value of R is obviously a constant value, molar gas constant, 8.314. Then they have also derived an equation. I'm not going to go into derivation, but PV equals to 1 by 3 NM. This is root mean square value. What is a root mean square value? But what does that mean? Okay, so if you consider normal distribution of molecules, the number of positive, because velocity is a vector quantity, the number of positive values will be almost equal to number of, not almost, actually if they are normally distributed, be actually equal to number of negative values. In that, what will happen? If you first total it, then the number will become 0 and the average also becomes 0, right? But if you square it first and then average it and then find the root, then you have an actual value which tells you what is the average velocity. It is, in other words, average velocity. But because velocity is a vector and it has negative values, you need to find out, to find the actual magnitude, you need to find out the root mean square value. You square it mean in and then root it again, so you find the correct value, right? Now, what does root mean square mean? This is root mean square. This is the symbol for root mean square. This is root mean squared squared. So this is just root. Sorry, this is just mean. Right? This is, in other words, mean velocity. Right? If they ask you what is RMS velocity, then you find the value of this thing, and then you root it to find the root mean square velocity. No, write it in the form of root mean square, because root mean square is also used in current, it is also used in voltage, right? It is also used in power actually. When it's written out, what is 1 by 3, what is n by 5? So उसमें c squared. You write it is root mean squared velocity. But you explain how you find root mean square or why you use root mean square, because probably that will be 2 marks, right? And they then have taken this volume over here, so it becomes density. So 1 by 3 density into c square, right? I believe this was the equation. Yes. Over here they have again done some mathematical gymnastics, right, that we have already seen in class, by the way, है ना? So 3 by 2 kt is equal to half m root mean square, right? What is that showing us? That is showing us that k is constant, mass is constant, so T is actually directly proportional to c square, or T is directly proportional to the kinetic energy of the particles. The greater the temperature, the greater the kinetic energy. So one concept that you can learn from here is that if you go on decreasing temperature of an object, the particle's kinetic energy will decrease. You will reach such a point where the kinetic energy becomes, and can you remove any more heat from that object then? Which gives us the concept of absolute zero. Right? One more concept is that PV is a constant, right? So if you increase the pressure, the volume goes on decreasing, right? And from here, or not this, but volume is directly proportional to temperature. The lesser the temperature, the lesser the volume, right? If it's an ideal gas, it will go on compressing till zero volume, right? Because ideal gas has, the particles have negligible volume compared to the volume they occupy. So as you go on decreasing the temperature, the volume will also decrease. Eventually volume will become zero theoretically. Can you decrease the volume anymore? No, ideally no, and that is again absolute zero. Practically, hence, from these two observations, practically absolute zero is unachievable, right? No gases can have zero volume. Make sense? Okay. So that is your ideal gases. So according to me, these are the two chapters. We can start with doubts of these chapters now. You can tell me the questions. I will try. So last week four to FM 9. Last week हाँ तो कुछ बोल क्या कॉर्नर में हाँ ऑफिस में चेयर ની પાછળ કોર્નર માં બધું પડ્યું સર 4 to શું આખું પેપર ક્વેશ્ચન નંબર લાઈને મને થોડું ફિઝિકલ કોપી જોઈશે ને બ્રધર કેવું લાગશે નહીં મજા આવે સોફ્ટ કોપી ચાલશે સારું લાગશે યુટ્યુબ પર કેવું લાગશે ઓ સર આઈપેડ વાપરે સર માસ્ટર પેલો ફોર્મ્યુલા આપણને દિવસ વી હેવ નોટ રીલી લર્ન ધીસ which formula સર મેં લખેલો છે સર એટલો મારીશ ના મોદી ઉપર પેલો okay so we have question from 4 to FM 19 paper code 9702 right so we have question number 3 and your doubt is part C2. Part C2, use your answer in 1 and expression in B to determine the density of the liquid. What is that expression? Expression is A is equal to minus A rho G upon M into X, where X is displacement, A is acceleration, right? What is capital A over here? A is yes, this is cross-sectional area, this is density, this is 9.81 and this is the mass of the cylinder that is oscillating, right? Now if everything is known, this can be compared to A is equal to minus omega square X. So you write omega square is equal to A rho G upon M and therefore if you have this, this and this is the answer to C part 1. You can find out the value of density. Right? Yes. Then next question. Same. 4 to 1. 4 okay. 4 to 4 1 MJ 2 3. Okay. A steel sphere of mass 0.29 kg is suspended in equilibrium from a vertical. Okay, it is suspended like this. This has a mass of 0.29 kg. This length is 8.5 centimeter. Then the center of the sphere is 8.5 centimeter. It is now set in motion so that it is moving in a horizontal circle at constant speed as shown. So it is moving in this circle something like this, right? So it's rotating like this. That is what it means. Sir, okay. Right? It's not just oscillating, it's going in circles. The distance from the center of the sphere to the top of the spring is now 10.8. So in this situation where it is going in circles like this, they are saying that the distance from the center of sphere to the top of the spring is now 10.8, right? It was 8.5 initially, now it's 10.8. They have given that this angle is 27 degree. Explain with reference to the forces acting on the sphere why the length of the spring in the figure 2.2 is greater than in figure 2.1. Because there is, why has the length increased? So what? Centripetal also act now. Because it is going in circles, there must be a resultant force. This resultant force also works in giving the tension to this spring, which acts as a force to elongate this spring, right? So basically, if you draw a free body diagram over here, right? Let's say this was your, what is it? It's a steel sphere, right? This is the tension. This will be mg, right? But there will be a m omega square r force over here. Correct? Makes sense? है ना? And from here I can say that T, if this is your theta, then this should be T cos theta and this should be your T sin theta. So you can easily find m omega. If m is known, omega square can be known and r is known, you can find out the value of T cos theta. Right, so then you can find out the theta is already given, right? In this it says that this is 27, right? So how much should this angle be? If this is 27, this has to be 27. This is 90, right? So basically this angle is, okay, 90 minus 27 I was going to say. So you can also, yes, it's 63 is correct, but if that was theta, this is 90 minus theta, basically, है ना? So this is 63. So you can directly equate is equal to mg, right? If mass of the steel sphere is known, then you can find out the value of T. Once that T is known, you can find out the value. Mass is again known. You can find out this is a triangle. You can find out this radius, right? And therefore you can find out the omega. It is still not asked, but I believe next part यही होना चाहिए. Right? Show that the radius of the circle is 4.9. You will use trigonometry to prove that this base is 4.9. Show that the tension in spring is 3.2. The answer over here should be 3.2. The spring obeys Hooke's law. Calculate the spring constant. If you know the value of T, you can find out 10.8 minus 8. What was it? 8.5. This and T over this thing, you will easily find out that what is the value of K, because K is equal to F by X, right? Then you have used the information to determine centripetal acceleration of the sphere. You can use this. એટલે force માટે ખાલી આપણને m omega square આગળ કન્સિડર કરવાનું કેમ કે mg ઓલરેડી 8.5 સુધી આવી ગયું હતું. Oh, right. અહીંયા, right? Okay, so this m omega square r should have been the answer, right? And centripetal acceleration omega square into r. Calculate the period of the circular motion. If you know omega, 2 pi by t will give you the value of t. है ना? So that is your answer. Okay, you have 4-2 FM21, right? The question is 4. Defining equation of simple harmonic motion is this. State the significance of minus sign, that they are in opposite direction, right? A trolley rests on a bench. Two identical stretched springs are attached to the trolley as shown in figure 4.1. So this is attached over here with a spring, then there is a trolley which is attached to another spring, and then there is this, right? All of this rests on a bench. So the unstretched length of the spring is 12 centimeter. The spring constant, so K is equal to 8 Newton per meter. When the trolley is in equilibrium, the length of each spring is 18. So L0 is equal to 12, L is equal to 18. So this is also 18 and this is also 18. Okay. The trolley is displaced 4.8 centimeter to one side. Okay. And then released. Assume resistive forces on the trolley are negligible. Show that the resultant force on the trolley at the moment of release is 0.77 Newton. Right. So see, can I also construct it like this to make it very simple? This is first spring, this is second spring, and is connected to trolley. Right. Trolley is free from one end. It is connected to trolley. Right. What is the length should be 24. But initially the length is 36. So how much force is it under?
36 minus 24.
Right? Definitely. You find x first, but you don't need to find that. First, you have to understand that it is pulled to 4.8 centimeter on one side. So you have gone from 36 to 31.2 centimeter. Right? Now you find out that 31.2 minus 24 is how much? They have said that first, this was in equilibrium at 18 and 18. They have said that first हम थोड़ू ले ली दो, तो 4.8 centimeter towards one of the spring and then released. They are asking first at the moment of release find out that the resultant force is 0.77. हाँ, चल ना करियो तो अभी लॉजिक तो आज चल बेटा. ओके એવું એક્સટેન્ડ કરીએ બસ આવું જ આવશે કે right. So 18 plus 4.8, right, and this is 18 minus 4.8, right? Here what will happen?
So what will be 6?
Can 6?
18 original length plus extension 6 plus 4.8 minus 6 plus into 6 plus 4.8.
Very nice. 6 plus 4.8, 6 minus 4.8, right? What will this be? Huh? Upon original length, what will this be?
12. 10.8 into the answer. 6 plus 4.8.
But આ બેવની વચ્ચે શું ઓપરેશન આવશે? That is my question. How will you connect these two equations? क्यों? Why? Add કરવું જોઈએ. કેમ add કરવું જોઈએ? Because we are finding the total length of the spring. But what will that give you? That will give you 36.
Minus
30. Add થયું. तो मैं फर्स्ट कंस्ट्रक्शन में यूज किया. समझ रहे हो प्रॉब्लम? समझ रहे हो क्वेश्चन में कि ये क्वेश्चन इतना डिफिकल्ट क्यों बन रहा है? है ना? It is just that you see, if you compress this here, right, this will stretch. That is what you are considering. So what has basically happened? It will again try to go into equilibrium. You must, to understand this properly, you must first make it into a single spring and then you can do this, right? But let's understand it like this. Oh મિત્રો શું છે?
ખબર નથી કે માઇનસ માઇનસ 0.8 આવે છે.
પ્લસ કરીશ તો
0.8 is closer to 0.7.
Okay, but I think the answer will come to some 0.768 ऐसा कुछ आएगा and then 0.77 आएगा, है ना? तो कैसे आएगा? कैसे आएगा? चलो everyone कैसे आएगा?
Multiply.
Why would you multiply?
0.75 division.
Okay, see, the logic should start from here that k is already given to you, right? If you want to find f is equal to kx, है ना? Make sense? So, if this was a situation where you would be stuck in exam, you can easily find the value of x over here, right? What should x be? What should x be? We are still confused what to do with this. It was already 12, it is still 12. We're not sure what is x. What should have been x? If this equation upon it, what should x? I have no idea. 0.0. Okay. Can you just say that 0.7 and then multiply this by 100? Will it give you 9.6 centimeter something? है ना? But how will you show that this is 9.6 centimeter? क्यों माइनस होगा बेटा? क्योंकि 10.8 माइनस वो करेंगे तो 9. No, obviously वो I know, but why is there a negative sign?
Because spring is pushing it from like this to this side, this side to result final. The difference between the maximum length and the
difference between this will give you the total change in length.
9.6.
So this will give you 9.6 centimeter. Change it into meter, right? Obviously, because this was a proof question, we could go like this and actually find out. But what does this mean when it is in equilibrium? You just find out the total change. What is total change? 4.8 and 4.8. So instead of doing all of this, you can start 4.8 plus 4.8 is 9.6. This is the total new change in length of the spring, right? You can use k is equal to f by x and therefore f is equal to kx. The value of x is 9.6 upon 100. The value of k is 8. 0.768 will give you. I remember this question somehow. Right, the next question is mass of trolley is 250 gram. Calculate the maximum acceleration of the trolley. So,
I remember it.
Why? F is equal to ma, right? And once you know a minus omega square x, find out the value of omega and find out the value of 2 pi by t, right? That will give you the final answer. Very nice. So we have a question 41ON18. अच्छा guys, I have found out that ऐसे टेबल वाले क्वेश्चन थोड़े ON में ज्यादा है, FM में चांस कम है. So if you really like these questions, I'm sorry for you. But if you don't like these questions, I'm happy for you. है ना? ये क्वेश्चन करते हैं.
Change in Q1.
हाँ? Okay. Just a second, guys. ऐसा कुछ अपने पास. This is 280 Kelvin. This is 332 Kelvin. Boss, hey. This is 1125 centimeter cube. This is 950. I'm drawing the diagram. Right? This is question number 2, by the way. This is 372 Kelvin. This pressure is 2.80 10 to the power 5 Pascal. This pressure is 2.10 into 10 to the power 5 Pascal. Right? So they have explained this whole thing. At point P, gas has so much volume, so much pressure and so much temperature. Right? It is heated at constant volume and 97.0 joules of thermal energy is transferred to the gas. Right? It is at point P over here. So this is point P, this is Q and this is right. So they have said in the table, next page, right? Part B and then there is a table. Some energy changes take place during the cycle PQRP as shown in figure 2.2. Thermal energy transferred to gas is 97 and from Q to R work done is 0. Sorry, From P to Q, this is the change. From Q to R, energy change is 0. What should be from R to P? This is heat energy, right? If we write the same thing about work done, they have said work done here is unknown, work done here is minus 42.5, and work done here is 37.0. They are asking what is the change in internal energy, right? If you notice, these two values are given. So for Q to R,
We can find
delta U is equal to minus 42.5, right? What else can you find out? Here they have already told you that there is no change in volume. So this should be 0. So for P to Q, you can find out delta U is equal to 97, and for R to P, the total should be 0. Right, so what can you say? Delta U is equal to 97 minus 42.5, or rather minus 4, sorry, whatever answer you get, write a negative sign in front of this, right? Only then this total. કેમ હા આ બેવનું total 97 થવું જોઈએ, but negative 97, only then the total internal energy change is 0. This should be 0, right? You adjust this value in such a way that this total becomes 0, right? What is that value? So minus, so you find this is minus 54.5. Once you know that this is minus 54.5, can you work out that delta U is equal to Q plus W? You know this is minus 54.5. You have been said that this is 37. Can you find out the value of Q?
yes.
That is your answer, and that is the table 17.5. State the total energy change in internal energy of the gas during the complete cycle. The complete cycle, the energy change is 0 because the Q is converted to W.
Oh,
Something like that. So,
17.5 minus 91.
okay. On figure 2.2, complete the table, and that is your question. I will take next questions from the 11 to 1 session. You can come to me, find out a lot of answers. Okay, bye bye, see you.